All right, so I'm going to go back and I'll explain what I just did to get to this point. But what I just want to talk about right now is the programming aspects. I want to do this as a review. Talk about variables, talk about classes, talk about functions, talk about arrays and collections and those concepts. All right? So, anybody, what is a variable? Just articulate to me what a variable is.
Something that holds a value.
Something that holds a value. Yes, what is that something?
Something it stores it and you can call it later.
Okay. Stores it. Okay, stores it, you can call it later.
Space and memory.
The space and memory. Okay, that was the piece I was looking for. All right. So when I am presented with this new project, does everybody know what the static void main is? If you took Java, you should hopefully know what static void main is. It's that entry point into your application. When your program starts, this is the first thing that runs. All right. So to declare a variable, it requires two pieces. The data type, the type of information that you're storing, and the name of the variable. It's the human name that you're giving to that memory address. The data type tells the computer how much memory to allocate to carve out for that variable. All right? Simple example. Int age. If I need to zoom in more, I will. You guys good in the back? So what this tells the computer is I need a space in memory big enough to hold an integer, a number. So I need the operating system to carve out enough memory in the computer's memory and give me a reference to the first position in memory, a number, it's an integer as well. So if that first memory address is 100, it comes back and says, I've carved out space 100 to 108. That's the space for your integer. It starts at 100, it goes to 108. I'm now calling that age. So we now have a variable, a place in memory where we can store a number. The integer also tells us that we can only store numbers in there. Does everybody know what a string is? Show of hands. All right, what's a string? Somebody.
Text.
Text. How do you identify it that it's text? Quotes. Any piece of text, any characters you put around quotes, or put quotes around, it's considered a string. So you cannot take a string and store it in an integer variable. It is looking for a number. So we put an age here, we say 20. That number 20 gets converted into bytes. Those bytes get written to memory. Later, when we do a console.write line, and we write that age to the console, that number 20 gets picked up out of memory, it's passed to this function writeLine. It takes those bytes, converts them back into a number. That number is technically then converted into a string, and it's written out to the console. We run this app. Super tiny, little 20 right there. That's how that works. I like to say it's not rocket science. It's computer science. So, age 20. We can create other variables. Date time, birth date. Again, we're saying, operating system, we need some memory carved out to store a date time type. We want that memory carved out and we want it called birth date. Every time we call birth date, give us that memory address. Maybe it's 109. 109 to, I don't remember how big a date time is, but let's say it's 19 to 120. Anytime we call that variable or set something to it, we're putting bytes into memory in that space of memory that we're just calling birthday. It's a label for that chunk of memory, birthday. So we can make variables and call them whatever we want. Doesn't matter. I can change it from birthday to applesauce. It doesn't matter. The thing is that whatever name we give it is relevant to us. We understand it. And the type of data that we're storing is relevant to what we're trying to do. So you wouldn't store somebody's name in an integer field. You wouldn't store their name in a date time field. Because their name is a string. Their name is text. It's not a date. So how do we get these types? Is that a fair question? Where do these types come from? Does anybody have an answer to that question? Okay. Classes. So we have two different type classifications in every programming language. We have what are called primitive types, and we have user types. User is a relative term, and I'll explain why in a minute. Primitive types are the basic fundamental types that the computer understands. Typically, in a operating system or in a programming language, there are four basic primitive types. And then there are subtypes and extensions of types. But basically, you end up with four primitive types. Anybody want to take a guess on what those four types are? I'll give you a hint. You got two up here, and one of them is a primitive. Go. Int. So an integer, a whole number value, is a primitive type. String. In the .NET framework, in the .NET language, it is a primitive type. So, char is a primitive type, so that actually gives us 5. So yeah. Long. I always get that one mixed up. A long is technically not a. Within the .NET framework, it is a primitive type, but it's just a long integer. So it's an extended integer. So it falls kind of under that integer classification. So yes, I'll give you that. Yep. A double is a floating point, and that's the other classification is floating point numbers. So you have floats and doubles and decimals. Okay, we got one more. Boolean. It's off or it's up. True or false, right? Okay. So, you've got Booleans, you've got characters and strings, you've got integer whole numbers, and you've got floating point decimal numbers. From those four, you can pretty much make up any other type you want, which brings you to user types. User types utilize these primitives to make kind of like super types or classes. All right? I'll let that sink in. So your super types basically declare variables, bundle them together, and create these new units, these new types. So a date time is a user type. It's actually based off of not a class, but a struct. I won't get into the differences at this point, but it's basically taking a whole bunch of integers and putting them all together underneath one umbrella called date time. Visual Studio tip, if you don't know what a type is, click on it and hit F1, it will take you out to msdn.microsoft.com and it will bring you up the documentation. Nice. That is if it's from the .NET framework. If it's something else you downloaded, then you got to go look that up. All right, so we're going to look at the members of this date-time type. So we have constructors. Does everybody remember constructors? Okay, all right. Somebody tell me what a constructor is.
Isn't it like on the interface, like the first thing that you put, so that like when you enter the interface, it knows what to do?
Yes, I understand what you're saying. So yeah,
Is it create a new instance of an object?
yes. So both of these combined. So whenever you create a new instance of an object, it is the method or function that is called that initializes the values of that class. So it's the first thing that happens when you create an instance, whatever steps you want to go through. So this is the definition for the constructor. We'll skip that for now. Let me zoom in on this for you guys in the back. Oh, collapse, collapse. All right. We have fields and we have properties. I will get into that later. But we have these couple fields here, and then we have these properties. We have date, day, day of week, day of year, hour, kind, millisecond, and there's a whole bunch more. Each one of these properties, you can think of it as a variable for now. And that variable that's not the right one. Day. Has a type. That type is an int. So what day does this date time refer to? Well, your days are typically 1 through 31. It's one of those numbers, right? It's an integer. So we have a variable that holds the day. We have a variable that holds the month. That is also an integer. Year, also an integer. Minute, also an integer. See how we're utilizing these primitive types and we're just bundling them together into something called datetime? So this datetime class simply has a collection or a series of properties, of variables, that are integers that together represent datetime. Another example would be if you created a class that represented a student. You're a student. We create a class that represents a student. Now, creating that class, you're creating a blueprint of what a student looks like. So what kind of properties does a student have? If we're trying to describe a student, or just describe a person, what properties does someone like that have?
First name, last name, student ID, birthday.
Right, so first name, last name, student ID, birthday, those are great. Well, here, let's do this. Let's create a class. New, add class. So I'm going to add a class to this project. Let's call it a student. So tiny is the text. So to create a class, we do public class student. We'll get into public and private later, but for now we'll stick with public. Is that good enough size for the guys in the back? Okay. So we had first name, last name, student ID, birth date. All right? This is not good syntax, it won't compile, so just bear with me. We're getting there. What data type primitive, or if you can think of an existing user type, would we use for first name? String. Last name?
String.
Student ID.
String.
All right, I got int and I got string. And what?
It depends.
It depends. All right, why?
Depends on what the format of the student ID is.
Okay.
The UC could be a string
Yes. Why?
because it has an M in it.
There's an M in it. So, now, do you assume the M and just store the number? Or do you explicitly store the M, which then requires you to make it a string? Food for thought. All right. Who wants it to be an int? Who wants it to be a string? Who doesn't really care? I knew there was a handful. I was like, that wasn't everybody. All right. The I don't cares really don't count. So, string it is. Birth date. What type? Date time. That was kind of like a trick question, but I figured you'd get it. All right. So we've now created the blueprint for what a student looks like. So now we can create what are called instances of this class. So if we have a class of, this is a class of 23. So if we have 23 students in here, we can create 23 separate variables. Student 1, student 2, student 3, student 4, all the way up to 23. And we now have 23 variables that all independently store a student. And they store different students. They're different spaces in memory. And when we say create new student, when we come in back to our static void main, and we say student 1 equals new student, I've done two things here. Let me break that down for you. On the first line of code, I told the operating system, go find some memory in the computer that'll fit a student. Now the operating system's like, a what? A student? I know ints, I know strings and chars, I know floating point numbers, I know booleans. I don't know students. So the operating system and the framework together are going to say, oh, so really you need a string, and next to that you need another string, last name. Next to that you need another string, student ID number, and then next to that you need a date time, which is int, float, int. All of that together is a date time field. But you've got day, month, year, hour, minutes, seconds, milliseconds, day of the week, time zone. I think they recently added something about lunar standing, which I don't know why, but somebody's using it. All of that is packed inside of date time. So just because I said, hey, I need a new date time, it's not like, sure. It's like, you got all of that going on. But for us, we just say, give me a new student. We didn't have to declare these four variables times 23. That'd be a really big static void main if you had to do student 1 underscore first name, student 1 underscore last name, student 1 underscore over and over and over, right? So by packaging them together into a class that we call student, we just have this one unit of work, if I can use that term, this one unit student that we just create multiple instances of. So at this point, we've declared a variable, which means, computer, give us the starting memory point, 100, and then carve out enough memory and reserve it and allocate it to us to fit that student. So now inside of that memory, it's been allocated, reserved, and assigned to us, and we've been given the first point in memory, 100. We now have this giant empty block of memory that has nothing in it. Nothing. Anybody ever run into a null reference before? You hit that null reference because you reference the variable that has nothing in it. When we initialize our variable, we're initializing it to say, create a new string and put an empty string in there, double quotes on both sides with no text in the middle. That's our first name. Initialize that last name, double quotes, no text in the middle. Student ID, double quotes, no text in the middle. Initialize that date time and actually put values in each one of those memory blocks. So all of those numbers that are month, day, year, they all get initialized. That constructor goes through the process of setting those up. For a date time, it defaults out to month 1, day 1, year 1. That's what that date time comes out to be when it first gets initialized. All of that goes through in this one line of code. Student 1 equals new student. Without it, you're just referencing empty memory. So we now have this class. We have this construct that we can use in our programs. Now I did this on 2 lines. We can do it on 1 line. We can declare and initialize all at once. We did that up here with this int age equals 20. If we just say int age semicolon without the equals 20, take a guess, what does age initialize to? Wrong answer. That was kind of a trick question, I apologize. Your primitives are considered value types. So they actually initialize by default to a value regardless. So your booleans always initialize to, guess? False. Your integers always initialize to 0. Your floating points initialize to 0. And your strings initialize, no, those actually go null. Your chars initialize to an empty character. Strings are a weird one. I'll get into that in a later lecture. So, your primitives typically initialize to a default value. Your user types, like date time, the reason I have this green squiggle under here is it's telling me I declared it, but it's never used. Well, this, oh, it gets confusing. I won't get into it today. This is considered a struct. It's a value type. I'm just giving you the 30,000-foot view. Structs default initialize. They can't be null. I'll get into that in a later week. This is review. So, do you guys know about like value types versus reference types? Yes? Oh, that makes me sad. Okay. Oh, you know value types versus reference types?
I think so.
All right. You want to give me the quick?
I think value type actually hopes to store the value of the data. Reference types do that. So like an array. If you think the copy of an array, it doesn't copy the values. It references to the original memory space.
Yes.
That values are actually stored.
Yes. Yes. Correct. Okay. I know where you're going, and you've got the right concept. So, all right. I'm here. I'm gonna do this. Value types. Whenever you say you declare int a, you need a visual. Everybody needs a visual. Value types. I'm just making a function called value types. Int A, int B. Okay? Ints are value types. If I said A equal to 10, and then I say B equals A, now let me do it this way. So this is 10. This is 0. A equals 10. And B equals 10. Okay? If I then say A equals 5, A equals 5, but B still equals 10. Let's contrast that. Well, let me explain, and then I'll contrast that. So what happens is I set A equal to 10. 10 is the actual value stored in memory. B I initialize to nothing. It's 0. It defaults to 0. It has to have a value, 0. When I say B equals A, I'm taking the value of A. I'm copying that value and I'm storing it in B. So now A holds 10 and B holds 10. When I change the value of A, I'm only changing the value of A. A and B are not linked together. So then A becomes 5 and B becomes 10. That makes sense, right? Does that feel intuitive to you? Okay. Reference types do not do this. And this is a place that confuses people. So if I do string 1, string 2, I'll say this equals Kevin, and this equals nothing, right? That's the equivalent of what we did above. If I do string 2 equals string 1, this means that string 1 equals Kevin, and string 2 equals Kevin. Still makes sense, right? If I say string 1 equals Gantos, this means that string 1 equals Gantos, and now string 2 equals Gantos. This is memory address 100. This is memory address 110. When I set string 1 equal to Kevin, the value of Kevin is stored in that block of memory that starts at 100. String 1 is not holding the value of Kevin. It's holding a memory reference to where in memory Kevin lives. So when I say print Kevin out on the screen, it goes to memory address 100, grabs the value out of there, and puts it on the screen. It feels like a value type, but it's actually referencing the memory address. When I say store string 2 an empty string in 110, it goes to memory address 110, and it puts an empty string in that memory address. So then when I say print out string 2 on the screen, it goes to memory address 110, grabs that value, and prints it on the screen. To you and I, we think that these string variables are actually holding those values, but in fact they're just referencing memory addresses. And those memory addresses are what are in your variables. And if anybody actually wants to know all the mechanics of how this works, I'd love to explain it to you. So if you want me to get into all the depth, but I'm not going to. But let me continue. So when I say string 1, take string 1 and store it in string 2, it's not copying Kevin. It's actually copying memory address 100 and storing that in string 2. So what happens here is string 1 memory address is 100. And the string 2 memory address is now also 100. So they still both equal Kevin, right? Because inside of memory address 100 is Kevin. So if they're both pointing to the same memory address now, that's fine. We can do that. No big deal. So then when we change it to Gantos, what are we updating? The memory address. So both variables now equal Gantos. Your user types, your classes, when you create an instance and then let's say you create 2 students. Like we did here. Oh, that's not what I wanted. Student 2 equals student 1. That same thing happens. Let me scroll that up for you guys. The memory address of student 1 gets stored in student 2. It doesn't make a copy of it. Now, yes, there are value types in there, within that, but it starts out a memory address that can be shared. And by design, all of your classes, all of your user types pass by reference. This gets to be important when you start dealing with functions and you start passing variables into functions and then that function does something to that variable, that parameter. You can start actually manipulating your input parameters and changing their values and not even realize it on the outside. Are there questions on that concept? Yes.
So how come ints don't reference the memory address?
That honestly is a language decision. That's something that has been carried from C and C++. In C and C++, you don't have this idea of pass by reference directly. And so if you get back to the languages of C and C++, they are all based off of value types. You can create a specialized type of variable called a pointer. Anybody ever heard of a pointer? I figured you probably have. Anybody else heard of pointers? Okay. Pointers hold the memory reference to that spot in memory and then how much is allocated. So when you have this pointer, you're basically just looking at that memory reference and you dereference the pointer as the term to get back to the actual value. Well, in C# and in Java, they kind of abstracted away from this idea of pointers because, frankly, they're kind of convoluted if you don't really have a good understanding of them. And this idea of referencing and dereferencing, and then you get into garbage collection. And did you guys cover garbage collection in your Java classes? That makes me sad. Okay. Aren't you glad you're in this class? I'm glad some of you are. I got some smiles. So there's this concept of garbage collection, which basically involves the operating system and the framework doing your cleanup of your memory after you're done using it. So by it going through and doing that memory cleanup, it can't really just give out pointers because the garbage collector may go through and clean up a memory reference that you're really no longer using, but you still have a pointer to it somewhere out here, and then it kind of gets really messy, and then you end up with null reference exceptions because you're referencing memory that's not yours, or you end up with Stack Overflow exceptions. You heard of these? Where you're referencing memory that's no longer assigned to your application, or you're referencing memory that maybe has been reassigned to someone else, and then you end up stepping on that program's memory because you're changing its value because you think it's yours, but it's theirs, and then you end up corrupting programs, or you end up writing viruses that cause that kind of thing to happen. That's kind of how those work. They start touching other people's memory. They start making changes to other programs, and all of a sudden, program X is executing program Y's code. And there's a hole. So, back to the question of why do you have value types and reference types, and why is that considered a value type? Because in C and C++, all of your primitives are all value types. So to make it easy for old programmers to understand new programming languages, they follow and model those conventions in the new language. And quite frankly, it just makes sense that things be value types because that's intuitive to us. It gets weird when you start dealing with reference types. But to gain the most control over your application and utilize the least amount of memory possible, reference types are important. Because if you can take a really big chunk of data and store it in one place, and have everybody look at that one big chunk of data, instead of making copies and copies and copies and copies and copies, it's more efficient for your program. It's more efficient for the computer. You don't want to have 10 copies of the same student floating around in memory because, well, frankly, because then you have 10 copies. You don't need 10 copies of the same student if the data is exactly the same. Yes?
So is there a way to like make a string equal another string without like changing the address it's looking at?
There are ways to do it, and it has to do with, a lot of it has to do with how you pass them into functions. So if you want to pass an integer by reference, you can do that, but you have to explicitly do it. It's not coming to me off the top of my head if you can make a pointer reference to an integer in C#. I know you can create pointer variables. I'll have to look that up, I'm curious myself now. But when you pass an integer into a function by reference, like let's say it's a function that is supposed to double the value of the integer. So you take that integer and you pass it in, and then you're expecting that value after you call the function that integer is double, you can say, I'm passing this by reference. And it'll do that work by reference, and then you'll get back the new value on the outside. So there are some means of doing that. But typically, you have to be explicit. So. All right. So let me make one more point, and then we'll take a break. If you are still struggling with the concept of classes, I'm hoping my explanation helps. I know I've kind of mucked it up and talked about a lot of other concepts, but they're relevant and they're important. But the basic fundamental that I want you to understand about a class is that your goal is to take primitive types and user types and group them together into a single unit and make that represent something. I often say that when you're creating a class and you're dealing with a problem, so let's say somebody comes to you and says, hey, I need you to build this scheduling application that allows students to go and schedule for courses. Well, when you sit down to think about how do I write this program, and you think about I need to build these classes to carry and model data and do things, think about the nouns in your problem. So if you're writing a student scheduling app, the two obvious ones should be that you need a class to represent a student, and you need a class to represent the schedule. Now, that schedule class is going to be complex. It's going to also include probably a class for a course that actually just describes the course itself. It's going to include a class that represents when the course is available. So that'll just be your date time. And then you'll have other classes that start to bleed off of that. That course is taught by a teacher. So you'll need to have a teacher class that represents that teacher and all of their information. and so forth and so on. So as you start thinking about how you build an application, especially when you're building an enterprise level application and you're interfacing with databases and doing all this work, these classes become a vitally important unit of work. Because you're dealing with lots of data above and beyond just your basics of here's an integer, here's a string. We'll start there, but we need to escalate beyond that so that we can build bigger and better programs. When we start getting into Windows development, we're going to be dealing with lots of classes and lots of variables. I'm opening this door. Does anyone else have? Anybody have any garbage? Everything you do in programming revolves around classes. So if you don't have a good understanding of what classes are, come see me after class and we'll talk about it and I'll try to clarify it more for you, okay? All right, so let's go ahead